In this video, we are going to see how to use the inverse matrices to solve systems of linear equations. There is no operation of division for matrices, and matrix multiplication is not commutative. These are the two important things we should remember in this topic. Not to solve matrix equation, say Ax equal to B, where A is a matrix, X is a matrix, B is a matrix. A is a coefficient matrix, X is the variable, it's x1, x2, x3, whatever I have. B is a constant matrix. If I want to find the unknown X, then I will have A inverse B. The reason why it cannot be B A inverse, the reason is if I want to multiply both sides by A inverse, then I get A inverse AX is A inverse B, and I know that A inverse times A is the identity matrix IX. So I times X is like 1x in ordinary algebra. This matrix algebra I is the unit matrix. So the product IX will be X. X is equal to A inverse times B. So if you want to solve a matrix, AX equal to B matrix equation, then your X will be A inverse times B. Now let us try to solve this system of equations in three variables. So the inverse of the coefficient matrix. We are not taking the augmented matrix because we are not trying to find the reduced to echelon form. Let's take the coefficient matrix and find the inverse of it. So the inverse of this will be, using our graphing calculator, we can easily get the inverse to be 3, 3, negative 1, negative 2, negative 2, 1, negative 4, negative 5, 2. So the solution is going to be this A inverse multiplied by B. B is the constant matrix 1, 1, 1. So when I multiply them, I get that as 5, negative 3, negative 7. So your x1 is 5, x2 is negative 3, and x3 is negative 7. Let's take another system. We have got again equation in terms of three variables. A is there. We would like to take the A inverse. So A inverse is there. Multiply that by the constant matrix 3, 1, 4. So that gives you 8, negative 4, negative 9, and those are the solutions to the system. If I have a matrix A like this, then the inverse multiplied by the constant is negative 6, 3, 4, and that will be the solution. Using inverse methods to solve systems of equation, we have to remember these points. That is, if the matrix equation can be written as Ax equal to B, the solution X can be obtained using the inverse matrix A inverse as A inverse times X. There are two cases where inverse methods will not work. That is, when the coefficient matrix is singular, because when the coefficient matrix is singular, you cannot find the inverse of it. And also, the number of variables is not the same as the number of equations. If I have 3 unknowns, but I have got only 2 equations, so it will not be a square matrix. That matrix A will not be a square matrix, so you cannot find the inverse of a non-square matrix, and hence we cannot apply this method, the inverse method, to solve problems. So I have given some examples here to solve. Again, x1, x2, x3 will be the inverse of the first 3 by 3 matrix multiplied by the constant. Again, here, if an equation is given as a system of equation, then you have to rewrite that in the matrix form, Ax equal to B, and then try to solve for x. Here, x1, x2, you can get the inverse for 1, 3, 1, 4, and then multiplied by constant. The same case for the second one. But in these cases, there are some operations to be completed. So for the first question here, I can pull that constant 4, 3 matrix to the other side and split that in the form Ax equal to B. First, you have to rewrite this in the form Ax plus Ax equal to B only then you can make use of the inverse of a matrix. You can easily get the inverse of a matrix and find the solution. So this video helped us to solve systems of linear equation using inverse matrices. But when we are using inverse matrices, sometimes it is not possible only when the inverse matrix does not exist. That is, the coefficient matrix is not a square matrix. That is, if we do not have enough number of equations there. If you have 3 unknowns, if you have got only 2 equations, then this method is not possible. And even when the coefficient matrix is a singular matrix, you cannot find the inverse of the matrix. Hope this video was helpful. Thank you for listening and thank you for watching.